Welcome to the lesson 23 of the Advent of SysML v2. This training series is brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kęstutis, and today we dive deeper into requirements modeling. Building on yesterday's foundation, we will explore how to formally specify requirements with mathematical precision. By the end of the lesson, you will know how to formally specify requirements with constraints and how to use requirement templates for reusability. Yesterday, we captured requirements using doc comments, plain English text that describes what the system needs to do. But what if we could do more than just document requirements? What if the system could actually check them for us? That's where formal constraints come in. Instead of just writing the cockpit must be big enough for Santa, we can write an actual mathematical expression that tools can evaluate automatically. Let's see this in action. On lines 71 through 79, look at the cockpit for Santa requirement. Instead of a doc comment, we now have a require constant block. This is our first step towards formalization. We are still using English here with the language keyword, but now the constraint lives in a proper model element, not just documentation. This means we could swap to a different language, like a mathematical expression, and the model would understand it. Now let's see a fully mathematical constraint. On lines 42 through 56, we have a requirement called sizing requirement. In lines 52 through 54, there's a formal constraint. To size must be greater than or equal to fit times minimum scale. When we plug in actual values, this expression becomes either true or false. That's the power. Tools can check this automatically. There's one more thing to notice here. On lines 49 through 51, we have an assume constraint. This captures assumptions that must be true for the requirement to even make sense. Here we assume to fit is greater or equal than 0. The value must be positive. If this assumption is false, the requirement simply doesn't apply. It's like saying, this rule only matters when these conditions are met. Now here's where the things get really interesting. That sizing requirement that we just looked at, it's not tied to any specific component. It doesn't even have a subject. It's what we call a requirement template, a reusable pattern with placeholder parameters. Think of it like a form with blanks to fill in later. Let's see how this can be modeled in SysML. On lines 81 through 89, we see how to use this template. The cockpit size requirement specializes sizing requirement and fills in those blanks. Line 85 says, for this requirement, to size means the cockpit volume. Line 86 says, to fit means Santa's volume calculated from his weight. And line 87 sets the scale factor to 3. The actual constraint logic, the math, is inherited from the template. We don't need it to write it again. This is useful for two reasons. First, consistency. Every sizing requirement follows the same pattern. Second, reuse. If you have 10 different something must be bigger than something else requirements, you write the math once and apply it everywhere. Formal constraints let you express requirements as checkable logic, not just ordinary writing. And templates let you define that logic once and reuse it across your model. With formal requirements, tools can identify contradictions and automatically evaluate requirements against designs. Your new challenge task is to extend yesterday's stealth mode requirements. Introduce a formal constraint for power capacity, then refactor it to use the sizing template from today's lesson. Check the blog post for task details. Share your experiences and feel free to ask questions in our community forum. Links and information how to access Syside cloud platform is available in the video description. Like the video, subscribe to our YouTube channel, and click on the bell icon to get notified about future videos. Take care and happy modeling!